Today we will be learning alternating current. There are mainly two kinds of currents. One is your direct current, which is also called DC current, and another one is this alternating current. Direct current can be obtained by a battery, and it goes from positive terminal of the battery to the negative terminal of the battery. A direct current has a constant value in a battery. So this is one current, and the another one, alternating current. As the name suggests, this current is changing current. Alternating, the literal meaning of it is changing. So current can be changed in different ways, and a sinusoidal variation sinusoidal alternating current can be obtained by an electric generator. We will be studying this sinusoidal varying current in this chapter, which can be generated by an electric generator. Now the literal meaning of sinusoidal, I am explaining here that if any quantity varies with the sign of any another quantity, or if the quantity is varying with cause of any another quantity, then such variation is called sinusoidal. Variation. It has a particular graph, so if you draw coordinate axis and put y along y-axis and x along x-axis, and by putting different angles like 0 degree, 90 degree, 180 degree, up to 360 degree, then you will find the value of y in terms of sin x. So sin 0 is equal to 0. Here you have one value of y. Sin 90 degree is equal to 1. So at 1 you will have another value of y. Sin 180 degree is again 0. So you have 0 value of y at 180 degree. Now sin 270 degree is equal to minus 1. So y becomes equal to minus 1. Here you have a point on this graph. Now sin 360 is again 0. So you have plotted different points on this y versus x graph, and when you complete the graph and draw a line from freehand, so you can get this kind of graph. This is your sinusoidal variation graph. So any quantity varying sinusoidally, it will have this kind of graph. So this current can be generated by a electric generator. So let me discuss you the schematic diagram of an electric generator. Sinusoidal varying alternating current is produced in a generator. So let us discuss in brief the schematic diagram of a generator. Here you have a schematic diagram. You can see that we have two pole pieces of a strong magnet, a north pole and a south pole. Magnetic field is directed from north pole to south pole. This is a uniform magnetic field. Then you have a rectangular coil placed in between these two pole pieces, This coil is fixed over an axle. Now this axle is rotated with uniform angular velocity led by the velocity omega by some external source of mechanical energy. So in hydropower plant, this axle is rotated with the help of running water. In thermal power plant, whereas it is rotated by the vapor of water. So due to rotation, this rectangular coil rotates in magnetic field, and so the field line through the rectangular coil varies. In this perpendicular condition, you can see maximum magnetic field line can passes through this rectangular coil. Highest value of field lines can passes. Now while rotation, when it become horizontal and parallel to magnetic field, in this condition you can see no line passes through the coil. Line is just parallel to this rectangular coil. Flux is not passing through the coil. So you can see that the flux through the coil changes due to rotation of the coil. Here flux is maximum when the surface area is perpendicular to the magnetic field, and when the area vector, here in this diagram you can see, when area vector a vector which is perpendicular to the area and has magnitude equal to the area of the coil. So this is your area vector. So when area vector and magnetic field both are parallel to each other, then maximum flux crosses through the area. Now when area vector and the field vector becomes perpendicular to each other, then you can see that minimum flux passes through the area. So it says that in one complete rotation, flux changes through the rectangular coil. And due to this change of flux, an EMF is induced, which is alternating EMF, sinusoidal alternating EMF. So by the Faraday's law of electromagnetic induction, an EMF is induced in the coil, and which is equal to minus of rate of change of flux. Here flux is equal to dot product of area vector and magnetic field vector. So this is equal to AB cos theta, where theta is angle between area vector and magnetic field vector. So when you put the value of flux in this equation 1, E is equal to your minus dAB cos theta upon dt. Here your area is a constant, coil area is not going to change, magnetic field also is a constant, so only varying quantity is cos theta, and actually the effective area through which flux passes, it varies. Effective area is given by A cos theta. This effective area varies. So on differentiating this equation, we find that E is equal to minus A constant, B constant, and differentiation of cos theta is equal to, this can be differentiated with respect to theta only. So when you multiply and divide by d theta, so this comes equal to plus sine theta and d theta upon dt. I have differentiated this quantity and I'm left with d theta by dt here. So E becomes equal to AB, and this rate of change of angular displacement is angular velocity omega, and you have here sine theta. So EMF induced is equal to E maximum sine theta, where EM is equal to AB omega. Now sine theta varies from +1 to -1. So maximum value of E will be when sine theta is put +1. So E maximum is equal to EM into 1. From here you can find that EM is actually E maximum. So this is called voltage amplitude. So you have E is equal to EM sine theta. This is the alternating EMF induced in a generator. This alternating EMF has a symbol which is actually an inverted S with two terminals. This is the symbol of an alternating EMF. Now if you try to draw a graph between alternating EMF and time period, here you have alternating EMF on y-axis and time period on x-axis. This is your time period. So EMF can be written in terms of E maximum sine theta. In one complete rotation, you will find that the rectangular coil has executed 360 degree. So this is your 360 degree angle, and in one complete rotation, the time taken is called one time period. This capital T is showing your time period. This x-axis is graduated in 4 equal parts, and each part is equal to 90 degree or T upon 4. So for drawing graph, if you put the first value of theta, that is 0 degree, sine 0 is equal to 0, so EMF becomes equal to 0. Here you get a point. You plot a point on this EMF versus time graph. Now when sine theta is taken as 90 degree, then sine 90 is equal to 1, and EMF will be equal to EM into 1, that is EM only. If you have EM value, Emax value over here, and in opposite direction Emax is here with a negative sign, then you have a point here on the graph at 90 degree. Now when sine theta is taken 180 degree, which is equal to 0, so EMF at 180 degree becomes equal to 0. On y-axis, the value is equal to 0. Similarly, we can plot all the points by putting value of 270 in place of theta. You will have a point over here, and finally at 360 degree you will have a point here. So when you draw a graph with free hand through these all plotted points, you get this kind of curve, which is a sinusoidal varying curve. So this is your EMF generated by a generator. Now we can apply this sinusoidal varying alternating current to circuits. In this circuit, it is containing only a resistor, so this circuit is called a purely resistive circuit. This is your purely inductive circuit, as it is containing a inductor with inductance L. Similarly, you have here a purely capacitive circuit. Now here you have a combination of a resistor and an inductor connected in series. So this is a series LR circuit. Similarly, you have LC circuit. In this circuit, we have connected a capacitor and an inductor. Here you have a RC circuit. A resistor and a capacitor are connected in series with sinusoidal varying alternating voltage. When all the three are connected in series, then this is called a series LCR circuit. Now all the electrical components can also be connected in parallel. Then you have parallel circuits. So let me start with the one that is called purely resistive circuit. Here a voltage, sinusoidal varying alternating voltage is given to this purely resistive circuit, and we need to find the alternating current produced in the circuit and what is the relation between alternating current and alternating voltage. So all these things we are going to find. Here we know Ohm's law. Ohm's law tells that V is equal to IR. Therefore, V, which is equal to Vm sine omega t, this is equal to IR. And therefore, I is equal to Vm upon R sine omega t. So, instantaneous current is written in terms of voltage and resistance. Now this I can also be written as Im sine omega t. So this is the value of instantaneous current flowing through this resistive circuit. Here Im is equal to Vm upon R. So current magnitude, current amplitude is related to voltage amplitude by Ohm's law. One complete rotation of the coil in magnetic field in which it is rotated through 360 degree, and it is one complete time period also. The current and alternating EMF both varies sinusoidally. So let us find the relation between sinusoidal EMF and sinusoidal current with respect to angle of rotation and time period. So what is time period? time period is time taken in one complete rotation. So let us take time period on x-axis, and in one complete time period rotation is of 360 degree. On y-axis I have taken instantaneous current and instantaneous voltage, this value. This is your instantaneous EMF and this is instantaneous current. Now on this axis the maximum value of voltage EMF is Vm. EMF cannot exceed to this value, and this is your highest value of instantaneous current, that is called current amplitude. Now by Ohm's law you can see that current amplitude is equal to voltage amplitude upon R. So when R is greater than 1, it is a positive number and it is greater than 1, denominator is greater than 1, then current amplitude will be smaller than voltage amplitude. So I have taken current amplitude below voltage amplitude. So in one complete rotation of the coil, it is rotated through 360 degree angle. Now when we graduate the x-axis at equal distances and part the distances by 90 degree. So here we have the x-axis graduated in terms of time period and graduated in terms of angle also. So when this angle is taken as 0 degree, so sine 0 is equal to 0. Your EMF E becomes equal to 0 at 0 degree, and so why the current also becomes equal to 0. So you get one point here. Now when sine theta is sine 90, that is equal to 1, then EMF E becomes equal to E maximum, E amplitude. So at 90 degree you have EMF or instantaneous voltage value V maximum. So for voltages we will be encircling 2 times. Now at the 90 degree current amplitude is equal to your instantaneous current. You have current of this value. When you put in place of theta 180 degree, so sine 180 degree here is equal to 0. So your instantaneous EMF E becomes 0 and I also becomes equal to 0 at 180 degree. So you get a point over here, and similarly in this fashion for 270 degree you will get an instantaneous voltage at this very point and instantaneous current at this point, and finally at 360 degree current becomes 0 and instantaneous voltage too becomes 0. Now let us draw graph passing through these points with our free hand, and we find a curve just similar to a sinusoidal curve. So as it is varying in terms of sine, we get a sinusoidal curve. Here you can see that at the time the current becomes 0, voltage also becomes 0. At the time T by 4, when voltage becomes highest, current also becomes highest. So you can say that the two quantities are in phase. This angle is called phase. So the two angles are same in the two equations. So in a purely resistive circuit, instantaneous current and instantaneous voltages are in phase. The two angles are same and in the term of sine only, so they are in phase. This quantity is called instantaneous EMF, this quantity is called instantaneous current, and the quantity here is instantaneous is your, it is your EMF amplitude, and here you have current amplitude. So yes, one more thing. In this graph you can see, in one complete cycle, half of the cycle is along positive y-axis and half of the cycle is along negative y-axis. So the net current or net voltage in one complete cycle becomes equal to 0. The average current or EMF becomes equal to 0, because positive value and equal negative value, when they are added for average, so they become equal to 0. You can find it analytically also. So alternating current, you can see that in half time period, the current is increasing from 0 to a highest value, current amplitude, and then it becomes to 0 in first half time period, and then it reverses the direction. In reverse direction, it increases from 0 to a maximum value, and in one time period, the sinusoidal varying alternating current again becomes to 0. Such a current is called alternating current. When current changes periodically in magnitude and is also changing the direction, then such current is called alternating current. Similarly, you can define alternating voltage. So in half of the time period, you can find that value of sinusoidal alternating voltage is increasing from 0, it goes to highest value. Here it has highest value and it then becomes equal to 0 in first half time period. And then it reverses its direction. It now flows in opposite direction and it increases from 0 to highest value. And finally in one time period it again comes to 0. So this is your alternating voltage. The voltage which changes periodically and also changes the direction of this voltage periodically, then such a voltage is called alternating voltage. In one time period, the average of instantaneous current becomes equal to 0. And average of instantaneous voltage also becomes equal to 0 in one time period. But the power dissipation is not 0 in one time period. It has some positive value as power depends on, from Joule's law of heating, power is equal to square of I into R. So power is not depending on simply I, it is depending on square of I. Square of any quantity can be only a positive number. So let me find the average of power. Average of power is given by Im sine omega t whole square from this equation into R, and average of all these things. So when you take out the constant value, current amplitude square and R outside, so you need to average the value of sine square omega t only. So sine theta varies from -1 to +1, but square of sine theta varies from 0 to +1 only, and average of this value can be equal to 0 plus 1 upon 2, that is 1 by 2. So average of this value is only half. Your average P in alternating current becomes equal to half of current amplitude square into R. Now you can see that this power in alternating current is different from the power in DC current. In DC current we have power equal to I square R. So the forms are different. And for our convenience, we introduce a new current which will replace this one. And that current is called from 1 average power becomes equal to IRMS square into R. Here I have introduced a new current IRMS, so that the form of power in DC current and in AC current becomes similar. Here you have similar pattern of similar form of the equation of power. So when you compare 1 and 2, you can get IRMS. Your IRMS square is equal to half of current amplitude square. Therefore IRMS is equal to root square of current amplitude by 2. Here this RMS justified the name of this current because it is root. R stands for root, so this is your root. Mean of square of current. So this is square of current and mean of it. So this is your IRMS. And its value will be equal to current amplitude upon root under 2, and therefore IRMS is equal to 0.707 into current amplitude. Similarly, you can find voltage RMS, VRMS also. VRMS is equal to voltage amplitude divided by root under 2, and this is equal to 0.707 into voltage amplitude. And this is why our current is very dangerous, because we measure this voltage, but we have a voltage amplitude which is equal to root 2 times the voltage we measure in a voltmeter. So the AC currents are very dangerous. It is having a peak which is root 2 times more than the voltage we measure. Now we know that current amplitude is equal to voltage amplitude divided by R. As per Ohm's law, it is obeying Ohm's law. So if you divide the two sides by root under 2, you get that IRMS is equal to V RMS divided by R. This is also obeying Ohm's law. So this is the current and this is the voltage that we measure, and it is obeying Ohm's law. You can find relationship between the various currents. When you draw a graph between instantaneous current and time period, so instantaneous current can be represented by y-axis. Suppose you have to find instantaneous current at an instant t, then you will draw a perpendicular line on instant t and then a perpendicular line on y-axis, current axis. This is your instantaneous current. This value is instantaneous current. And this value gives you the current amplitude. This is your Im. Now we know that IRMS is equal to 0.707 into current amplitude. So if you make 7 part, 1, 2, 3, 4, 5, 6, 7. Okay. So here you can have your IRMS. This will be giving you IRMS. Your IRMS current is mean of square of current amplitude. This is a mean current. So it will have a uniform value. Mean will have a constant value. You have two constant values, current amplitude and IRMS. But IRMS is smaller than current amplitude. You measure this quantity by ammeter, but current exceeds from this quantity to this value.